So if you've ever taken a physics class, you've probably heard of the formula. Kinetic energy is 1/2 mv squared. But what really interests me about this formula is the 1/2 mv squared resembled an integral a lot. So I just wanted to dive deeper into what this formula, how it actually comes. So the first thing I thought about is how change in kinetic energy is equal to work. And if you have a force distance graph, work is defined as this area. So it's from 0 to t. So work is integral of 0 to t f of, I'm going to call it r because I don't want to do dd, so dr. Now what I'm going to do is I'm going to substitute it in this. Change in kinetic energy is equal to go from 0 to t f of r dr. Now what I'm going to do is I'm going to use Newton's second law of motion that states that F is equal to ma. So I'm just going to change this to equal of 0 to t m a dr. Then I'm going to take the mass outside, and since acceleration is derivative of the velocity, I'm going to change that to dv by dt. So it's going to be m go from 0 to t dv by dt times dr. Now I'm just going to swap these two, so I'll get integral from 0 to t dr by dt and times dv. And derivative of the position is just velocity, so this is the same as m integral from 0 to t v dv. So we get kinetic energy is equal to 1/2 m v squared minus 1/2 m v0 squared. And since v0 is 0, we can cancel this out and you get 1/2 m v squared.